It's 45 student. Okay, good afternoon to all.
Good afternoon,
So,
Good
sir.
afternoon, sir.
Good
Good
afternoon,
afternoon,
sir.
sir. Good afternoon, sir.
today we will study. If I think in last class we have covered up about the stainless steel and their types, right? So today we will see about the effect of alloying element and tool steels. I think I will open this one. Effect of alloying element. Okay, I think 50 students. So, right. So I am going to represent my screen. I think I will be right. Okay, I think it is coming on your screen.
Yes, sir.
Yes, sir.
I will adjust. So we have studied about the these things, steels and cast irons and stainless steel. So uh, there are carbon percentage is there, magnet is there. If you see stainless steel, again chromium percentage is there, right? So they are having some effects on as a alloying element on the some steels and cast irons that we will see one by one, right? So there are numerous types of alloying element, right? I think about 20, right? 23. So how to remember it, right? One factor is there. So many alloying elements are there, right? So first what you have to do to remember is these things. You make one y-axis as a alloying element and x-axis is the your properties, right? Effects, right? So in that fashion you can means remember all these things, right? So again if you read day by day, that you can remember. That is one of the means type to remember that thing, right? So first thing is boron. Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. First thing is boron, right? So we have already studied about the mechanical properties, right? So what are the mechanical properties that improve or not improve with the alloying element, that we will see. So first one is a boron. Boron improves hardenability without the loss of machinability and formability, right? So hardenability or another term is there, right? Hardenability is nothing but the easy to hard, easy to get the particular depth of hardness is hardenability, right? Suppose I want only 2 mm hardness, right? 65 BHN value for 2 mm, right? On the surface only, right? मुझे सिर्फ 2 mm हार्डनेस चाहिए 65 BHN की, ओनली टॉप लेयर मुझे हार्ड चाहिए, राइट? अंदर का मुझे हार्डनेस की जरूरत नहीं है एज पर एज एप्लीकेशन दैट इज नथिंग बट hardenability, right? That may improve by adding boron, right? Machinability, easy to machine, and formability is easy to form. Right? That can be improved by addition of boron. Right? Next one is a calcium deoxidizes steels, improve toughness, and may improve formability and machinability. Third one is important, carbon. Right? You should know. Right? Carbon improves hardenability, strength, hardness, and wear resistance. Right? Wear resistance means there should not be any wear if there may be sliding motions or even rotary motions. Right? It reduces ductility, weldability, and toughness. कार्बन जैसे जैसे बढ़ता है वैसे वैसे आपको वेल्ड करने में प्रॉब्लम क्रिएट हो जाता है. Right? That is important. Next one is a cerium. Cerium controls the shape of inclusion and improve toughness in high strength, low alloy steels. It deoxidizes steel. Right? Deoxidizes steels means it creates resistance to your corrosion. Right? Fifth one is a chromium. This is also important, right? Already was studied in stainless steel. It
Sir?
resists corrosion. Yes.
सर आपने बोला कि सर जैसे कार्बन की अगर कंटेंट बढ़ता है तो वेल्डिंग करने में प्रॉब्लम आती है, तो क्यों होता है ऐसा?
क्योंकि वो आपका देखो वो वेल्डिंग आप करते हैं, इसका मतलब है दूसरा आप फिलर ऐड करते हैं या नहीं करते हैं, मगर इट शुड क्रिएट अ बॉन्ड.
ओके,
बॉन्डिंग क्रिएट होनी चाहिए, तो वो बॉन्ड क्रिएट नहीं हो पाता है. जैसे है कास्ट आयरन में, कास्ट आयरन की अगर वेल्डिंग आप कर रहे हैं, कौन सी भी वेल्डिंग, राइट, तो वहां पे बॉन्ड फॉर्मेशन का प्रॉब्लम आ जाता है. राइट, अगेन यू हैव टू गो to study about the this bonding, right? Chemically क्या हो रहा है, that is important, but as far as mechanical is concerned, they are not forming bonding, that's why it is not for welding. Right?
ओके सर.
So next one is chromium, right? Chromium improves toughness, hardenability, wear and corrosion resistance, and high temperature strength. It increases the depth of hardness penetration resulting from heat treatment by promoting carbonization. तो वही है, hardenability ही है इसका मतलब. बड़ी गेम है, राइट.
सर शुरू से रिपीट कर सकते हैं?
यस,
शुरू से रिपीट कर सकते हैं, मैं भी ज्वाइन हुआ हूँ.
या अभी आप 5 मिनट बाद जब आओगे ना और कोई आएगा फिर शुरुआत से करना. लेट मी कंप्लीट इट, देन अगेन आई विल टेक फर्स्ट 5 वन, राइट.
ओके,
राइट. Again, so sixth one is improve strength. This is the alloying elements, and what are the improvement will be there, right? By adding some alloying element, we are seeing that one. Sixth one is a cobalt. Cobalt improves strength and hardness at elevated temperatures, right? So cobalt is generally used in tool steels, right? Because if you add that one, right, the primary requirement of tool steel is to have a strength at elevated temperature. जैसे एक्स है आपका, एक्स क्या करेगा, एक्स से आप कटिंग करोगे किसी की, तो प्राइमरी कंसर्न इज एक्स का शेप डिस्टॉर्ट नहीं होना चाहिए, राइट. अगर वर्क पीस का टेम्परेचर ज्यादा है, राइट, एंड इफ यू वांट टू कट इट, right, so it should not be distort x means composition and shapes, and that is the requirement. So cobalt is generally used in the tool steel. So seventh one is a copper. Copper improves resistance to atmospheric corrosion and to a lesser extent increases strength with little loss in ductility. it adversely affect hot working characteristics and surface qualities. And this is the copper's
Have it done.
alloying element effects. Yes.
So, it is mentioned that copper improves resistance to atmospheric corrosion, but copper does get corroded. It forms basic copper carbonate. So, how is it offering resistance?
See, copper's actually as a alloying element. Generally, pure copper we are not using as far as mechanical applications are concerned. We are generally used as a brass, right? Brass and bronze. That is alloy of coppers,
Okay, sir.
right? But as far as copper content is there, there is a resistance for the corrosion, right? So pure copper we are not using anywhere, right? Yeah, unless utensils, right? In utensils, mostly we will use major copper elements. But as far as mechanical applications are concerned, we are not using pure copper. But in electrical appliances, electrical motors and that things, we are using copper wires. So it is written there, copper improves resistance to atmospheric corrosion. Right. So mostly we are not using copper in in pure form. Right.
Okay, sir.
Okay. So it is there, but we are not using it pure form. To a lesser extent, increases strength with little loss in ductility. It adversely affects hot working characteristics and surface quality. Lead improves machinability. It causes liquid metal embrittlement. Right. So what is this embrittlement? Right. So embrittlement means if you are having, suppose you have a shaft, right? It is rotating continuously in the bearing, right? But due to some lead percentage as a particular area, right? It is having some embrittlement effect, right? Embrittlement means in particular area, specific area, the strength will be lesser one compared to your whole shaft, right? So brittle material is having lesser strength compared to your other material. Just like a cast iron is having lower strength compared to steel. Right? In that respect, we can understand this. So it decreases the strength, right? But improves machinability. Machinability means easy to machine, right? So next one is and lead is very important as far as your environment is concerned, right? Nowadays you have seen one Maggie that some problems will created due to the Maggie's environmental issues are there, and I think that one petition was filed, right? Lead is very dangerous to the health, right? So even in as far as mechanical is concerned, right? Lead materials is not used in bearing, right? In previous days, right? Lead is used as a bearing material, right? But nowadays it is not used due to the environment concern. So Euro 6 with lead is banned, right? Even in Bharat term it is banned. Right? So next one is a magnesium. Magnesium has a same effect as a cerium, right? You can put same things of cerium. Manganese improves hardenability, strength, abrasion resistance, and machinability. It deoxidizes the molten steel, reduces hot shortness, and decreases weldability. Right? So as far as your exam is concerned, chromium and carbon is important, right? So others are also important, but they are actually linked to other subjects like just like a stainless steel and your cast iron and this only steels, right? That is important. You should know that. Molybdenum. Molybdenum improves hardenability, wear resistance, toughness, elevated temperature strength, creep resistance, and hardness. It minimizes temporary brittlement. Right? So molybdenum is also one of the key factor for the tool steel. Right? Tool steel में generally molybdenum, cobalt ये use किया जाता है, even chromium also. Nickel. Nickel improves strength, toughness, corrosion resistance and hardenability. Right? अगर कोई सा टूल स्टील में अगर आपको कॉम्पोजिशन पता है तो आप प्रॉपर्टीज लिख सकते हैं, राइट? अगर प्रॉपर्टीज पता है तो मतलब कॉम्पोजिशन यू कैन फाइंड आउट, राइट? दैट इज आल्सो निकेल improves strength, toughness, corrosion resistance and hardenability. Niobium imparts fineness of grain size, right? So कहीं पर भी देखो कौन सी भी पार्ट्स में आपका ग्रेन साइज अगर फाइन है मतलब छोटा है, राइट, तो उसमें हमेशा स्ट्रेंथ आपको ज्यादा मिलेगी. कौन सी भी चीज आपको डे टू डे लाइफ में भी अगर ग्रेन साइज आपका उस पार्ट्स का छोटा है तो ऑलवेज यू विल गेट द हायर स्ट्रेंथ. And impact strength, it lowers transition temperature and may decrease hardenability, right? Phosphorus improves strength, hardenability, corrosion resistance and machinability. It severely reduces ductility and toughness. Somebody else. Selenium improves machinability. Silicon is very important, right? Now this age is denoted by a silicon age, right? So previously it was a stone age, iron age, right? Now it's a silicon age. Silicon improves strength, hardness, corrosion resistance and electrical conductivity. It decreases magnetic hysteresis loss, machinability and cold formability. Next one is the sulfur. Sulfur improves machinability when combined with manganese. Manganese sulfide will be there, right? It lowers impact strength, ductility and impairs surface quality and weldability. Tantalum has effects similar to those of niobium, right? Same, you can copy there. Tellurium improves machinability, formability and toughness. Titanium improves hardenability and it oxidizes steels. Right? So titanium is very costlier one compared to your steels and right other materials. Tungsten has same effect as cobalt, right? So cobalt, tungsten, right? Vanadium, right? These are used in the tool steels. Vanadium improves strength, toughness, abrasion resistance, and hardness at elevated temperatures. It exhibits grain growth during heat treatment. Last one is a zirconium, has the same effect as cerium. Same you can copy. Right. So other residual elements are also there in steel, particularly steel. Right. So antimony and arsenic cause temper embrittlement. Right. Hydrogen embrittlement is also there. Right. Hydrogen severely embrittles steels lower. However, heating during processing drives out most of the hydrogen. Right. तो जनरली क्या है जो हाइड्रोजन एम्ब्रिटलमेंट है आपकी जो अगर इंजन की बात करते हैं तो इवन अगर नट बोल्ट्स में भी हाइड्रोजन एम्ब्रिटलमेंट हो जाता है सो इट विल क्रिएट द बस्टिंग ऑफ इंजन बस्ट हो जाता है, राइट? तो हाइड्रोजन एम्ब्रिटलमेंट में क्या होता है पर्टिकुलर एरिया पे आपका हार्डनेस कम हो जाएगी और वहां पे अगर लोड आता है तो वहां से क्रैक इनिशिएशन स्टार्ट होगा। क्रैक इनिशिएशन हो गया तो वो फ्रैक्चर हो जाएगा, और फ्रैक्चर होने के बाद 2 पीस में कन्वर्ट हो गया। 2 पीस में कन्वर्ट होने के बाद so that motions will be disturbed in the piston connecting rod and crankshaft, if you know about the some engines, right? तो उसमें वो टूट जाएगा, और टूटने के बाद वो अगर कॉन रॉड ब्लॉक के साथ लग गए तो इवन engine bustings will happen due to the hydrogen only, right? So next है nitrogen, improve strength, hardness, machinability. In aluminum deoxidized steels, it controls the size of inclusion. Nitrogen can increase or decrease strength, ductility, and toughness depending on the presence of other elements. Right? Oxygen slightly increases the strength of the reamed steel. Reamed means deoxidized steel. It severely reduces toughness. Next one is a tin. Tin causes hot shortness and temper embrittlement. Right? So this is all about the effects of alloying elements, right? So this is difficult to remember, I know, but one idea is there. You put all the alloying element and there some are the commons, right? Same as I have written zirconium, same effect as a cerium. So that manner you can remember that things, right? But this is important, carbon and chromium. So I will close that one. And got some idea?
Yes, sir.
Yes, sir.
Okay. That I will share right now, right, to you, to your group. Otherwise I will again. It is not happening. Share document presentation. It's not good. Okay, I will share afterwards, right, after this class. Now next topic is tool and wear resistance steel. Share screen. Right. It's coming on your screen?
No, sir.
No, sir.
Yes, sir.
Yes, sir.
No, sir.
No, sir.
Right. I think it's now coming on your screen.
Yes, sir.
Yes, sir.
Okay. So it's a simple topic, right? Tool steel and wear resistance steel. Right. So tool means cutting tool. Right. There are two types of tool: machine tool and cutting tool. Right. So cutting tool means your hacksaw blade, right? And your axe, right? And your single point cutting tool will be there for the other operations, right? You will see in the second year if you are from the mechanical production automobile, right? So these are the machine cutting tools, right, to cut the material. Another is a machine tool. Machine tools means simply a machine, right? So there, yes. Hello, any doubt?
No, sir.
Somebody. Okay. Okay, so what is a machine tool? Machine tools means there will be relative motion between two or more than two parts, right? So they are having some power, right? Your machine, simply a machine is called a machine tool, right? They are having some relative motion, right? They are having motors and all these things, right? Mechanism will be there. So we are talking about the tools, right? Tool and die steels, right? What is the difference between tool and die, right? So tool may be generally tool and die. Die means is just like a cavity, right? Cavity. Suppose you are making a cup shape utensil. Suppose one cup is there, a glass is there, right? How to convert it into glass from the sheet, right? So you have to force that material in a specific cavity, right? That cavity is made of steel, right? That is called your die, right? So if you compare male female parts, then it's called tools, right? Die is cavity, just like so. Tool and die steels are specially alloyed steels designed for high strength, impact toughness, and wear resistance at room and elevated temperature. Right? They commonly are used in the forming and machining of metals. So
सर एक बार डाई स्टील दोबारा बताना.
डाई स्टील में क्या है? डाई स्टील्स में देखो आपको कप बनाना है, राइट? स्टील का स्टील ग्लास का थिकनेस क्या है? जो आपका 2 mm है, राइट? तो 2 mm की आपने शीट ले ली जो कि स्टैंडर्ड अवेलेबल है मार्केट में, राइट? वो शीट ले ली, शीट में आपने क्या किया? उसको प्रेस करना है, राइट? प्रेस करना है मतलब आपको उसको फोर्स करना है कैविटी में, राइट?
Okay,
यू हैव
sir.
टू कन्वर्ट इट इनटू कैविटी, राइट? अगर उसमें ग्लास बनाना है तो उसको क्या करना है? आपको एक कैविटी बनानी है ग्लास के टाइप की, राइट? यू हैव टू पुट द शीट ऑन दैट वन एंड यू हैव टू प्रेस, राइट? तो एक मेल पार्ट होगा, एक फीमेल पार्ट होगा, एंड दैट ग्लास विल फॉर्म.
Okay, sir. Thank you.
Right? So the male and female parts is called tools, right? If you are talking about the dies is a female part, right? That is your die. Mostly these are recognized by tools and die steels, right? So it should have a higher strength than your workpiece material, right? तो उसका इसमें डाई एंड टूल स्टील्स में आपका हैमर्स आ जाते हैं, राइट? एक्स आ जाता है, राइट? आपका हेक्सा ब्लेड है, वो आपका मटेरियल आ जाएगा. So they are commonly used in forming and machining of metals. So this I have taken from the your Kalpak Jain book, right? So there are different types of steels. There is, I am not recommended to right, memorize all these things, right? They are nomenclatures, but high speed steel, right? It's important, right? You should know, right? High speed steel, first one, right? So there are two types: molybdenum base and tungsten base. Right? So others are there: hot work steels are there, cold work are there, shock resistance, mold steels, right? Special purpose steels, water hardening steels. Right? They have different nomenclatures. And if you are interested, there is a special handbooks are available. ASME books will be there for the tool steels only. Right? Right? So from this only you will get some comparisons, right? So no need to memorize all these things, just to go through that one. Right? So high speed steel, this is important, right? High speed steels, HSS, are are the most highly alloyed tool steels, tool and die steels. They maintain their hardness and strength at elevated operating temperature. there are two basic types of high-speed steels, M series and T series, right? Molybdenum type and tungsten type. M stands for molybdenum, T stands for tungsten. Right? So M series steels contain up to about 10% of molybdenum with chromium, vanadium, tungsten and cobalt. Right? So in alloying element, what you have studied? कि कोबाल्ट जो है, टंगस्टन, वेनेडियम जो है, हाई एलिवेटेड टेम्परेचर्स पे उसका इंप्रूव कर देते हैं, राइट? तो सेम चीज यहाँ पे आ गई कि एम सीरीज जो है उसमें मोलिब्डेनम परसेंटेज ज्यादा है और टूल स्टील जो है एलिवेटेड टेम्परेचर्स पे वर्क करने चाहिए. दे शुड नॉट डिक्रीज देयर मैकेनिकल प्रॉपर्टीज, राइट? स्ट्रेंथ हार्डनेस जो है मेंटेन करना चाहिए. T series contains 12 to 18% tungsten, right, with chromium, vanadium and cobalt as other alloying element, right? तो देखो चारों कॉमन्स है, आपको याद होना चाहिए मोलिब्डेनम और टंगस्टन. बाकी क्रोमियम, टंगस्टन, वेनेडियम, राइट, ये दोनों में कॉमन है. M series steels generally have higher abrasion resistance than T series steels, undergo less distortion in heat treatment and are less expensive. Right? So this is the comparison between T series steel and M series steels. High speed steels tools can be coated with titanium nitride and titanium carbide for improved wear resistance. Right? तो ये आप कोटिंग कर सकते हैं. So another tool steel is there, 1841, right? This is very important, right, as far as your syllabus is concerned for further study and all these things, right? 1841, this is important tool steel, right? So 18 is 18% of tungsten, right? 4% is of chromium, 1% is vanadium, right? So they are used in tools, right? Right? ये याद रखना है 1841, it's very important. Next term is diasteel. Right? There are F series are there, right? Hot work steels are designed for use at elevated temperatures. They have high toughness as well as high resistance to wear and cracking. The alloying element are generally tungsten, molybdenum, chromium and vanadium. Let's see the same composition, near our same composition is there, right? Cold work steels, right, they are designated by A, D and O series, are used for cold working operations. Other properties of the steel depends on particular composition. right? तो टूल स्टील में क्या याद रखना है? HSS, two types, M series, T series, right? M molybdenum, T tungsten, right? बाकी जो composition है tungsten, chromium, vanadium और cobalt, that is there. क्लियर हो गया टूल स्किल्स का? यस, आवाज आ रही है?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Are you?
चलो,
Yes, sir.
I will share this one, right? These two slides I will share with one element. Shit. To your A12, huh? Soro. So your group is A12 official, no? BME you have made, ना? BME का किस नाम से था आपका ग्रुप? हेलो
सर
सौरभ।
ME101।
अच्छा, एक मिनट। ME101। right. right. तो ये दोनों मैंने आपको ग्रुप पे पुटअप कर दिया है, राइट। राइट, आ गया ना ग्रुप पे? राइट, आ
Yes,
गया।
sir, right.
So next topic I want to take aluminum alloys. Right. So aluminum alloys, right? Aluminum, right? So they are their use is in the form of alloys, right? In the pure form also, just like your wrapping, right? Wrapping elements, right? जो आपने फूड को रैप करने के लिए यूज किया जाता है, एल्यूमिनियम फॉइल्स, राइट? That is also made from the aluminum alloy, pure aluminum, right? So if you see, there will be always be comparison between aluminum and copper, right? So most of but the use of copper is less compared to aluminum. Aluminum is abundantly available, right? But it is cheap also compared to your copper. So conductivity, if you compare the conductivity of copper and aluminum, which one is better one?
Copper.
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 Copper is better. So in motors we will see coppers, but the these things, right? Your transmission lines, right? They are not used by coppers, right? So again, cost is the concern, right? Loss is also concern, right? So aluminum and its alloys are characterized by relatively low density as compared to say 1.9 for the steels. High electrical and thermal conductivities and a resistance to corrosion in some common environments, right? Resistance to corrosion क्यों है? Aluminum oxides का layer form हो जाता है, right, on the surface, including the ambient atmosphere. Many of these alloys are easily formed by virtue of high ductility. Right? So this is evidenced by the thin aluminum foil sheets into which the relatively pure metal can be rolled. Right? So ductility is there, formability is there for the aluminum alloys. Aluminum alloys have high strength to weight ratio. Right? High strength to weight ratio means you can use for the एरोस्पेस इंडस्ट्रीज, राइट? जहां पे आपकी स्ट्रेंथ ज्यादा चाहिए और वेट कम चाहिए, राइट? सो फॉर द कार इंडस्ट्रीज, इफ यू सी फॉर द हाई स्पीड व्हीकल्स, राइट, so they are using aluminum alloys, राइट। जैसे कार्स में है, राइट, है, तो उसमें जो सिलेंडर ब्लॉक होता है वो एल्यूमिनियम अलॉय का होता है, मगर ट्रैक्टर में वही कास्ट आयरन का होता है। ट्रैक्टर और ऑफलोड व्हीकल्स जो भी है, क्रेन्स या फिर ट्रक्स, राइट, देयर सिलेंडर ब्लॉक इज ऑफ, राइट, कास्ट आयरन, बिकॉज देयर इज रिक्वायरमेंट इज ट्रैक्शन, राइट, ट्रैक्शन चाहिए, टॉर्क चाहिए वहां पे, राइट। और यहाँ कार में आपको स्पीड ही चाहिए, स्पीड इज इम्पोर्टेंट, ट्रैक्शन इज नॉट इम्पोर्टेंट, right? So again, there will be curves are there, traction versus and this speed, tractions and fuel consumptions, right? So you have to choose the optimum, right, intersection of the two curves, how this is there, right? Aluminum has a FCC crystal structure. Its ductility is retained at even at very low temperatures. The chief limitations of aluminum is its low melting temperature, right? It is, I think, this some melting temperature 660 degrees Celsius, which restricts the maximum temperature at which it can be used, right? So melting temperature is low compared to steels, right? That restricts its applications. But again, I am saying that by adding alloys, that melting temperature can improve, right? It may increase the melting temperature by adding alloying element. Engineering methods for transportation to effect reductions, right? In fuel consumptions, aluminum alloys are classified as their cast or wrought, right? अच्छा, reduction in fuel consumption, it should be upper, right? तो वही है, फ्यूल कंजम्पशन कम करने के लिए आपको एल्यूमिनियम अलॉयज यूज करना चाहिए, मगर एल्यूमिनियम अलॉयज का एक ड्रॉबैक जो है, एक तो स्ट्रेंथ का इश्यू है, एंड वन अदर थिंग इज इट्स अ लो मेल्टिंग टेम्परेचर, राइट? दैट मेल्टिंग टेम्परेचर कैन बी इम्प्रूव बाय एडिंग द alloys. So basically there are two types of aluminum alloys, cast and wrought, right? Wrought products made into various shapes by rolling, extrusion, drawing and forging. And aluminum ingots are available for casting. देखो उसमें रॉ मटेरियल कौन सा होता है, इसमें एल्यूमिनियम में बॉक्साइट, और जो स्टील और कास्ट आयरन के लिए रॉ मटेरियल कौन सा मिलता है, अर्थ क्रस्ट से आयरन ओर, aluminum ore is for the cast iron and steel, and bauxite is for the aluminum, right? तो एल्यूमिनियम का ये है कि एल्यूमिनियम जो कॉस्ट है, राइट, पर केजी इज हायर देन योर स्टील, राइट, एंड इट्स लोअर देन योर कॉपर, राइट? तो वो कॉस्ट क्यों ज्यादा है, क्योंकि उसको जो मेल्टिंग करने के लिए, उसको बॉक्साइट को प्यूरिफाई करने के लिए जो प्रोसेस है, दैट्स रिक्वायर वेरी ह्यूज इलेक्ट्रिसिटी, राइट? उसके लिए उसकी कॉस्ट ज्यादा है. सो देर आर, दैट इज अनदर पार्ट, राइट? There are two types of rods alloys of aluminum: alloys that can be hardened by cold working and are not heat treatable. Alloys that can be hardened by heat treatment, right? Not heat treatable, heat treatable. So new, I think one table is there, right, to have a look for the types, right? In slides you may be little bit confused, right? So wrought not heat treatable alloys, wrought heat treatable alloys, right? Cast heat treatable cast alloys, right? And aluminum lithium alloys, right? ये 4 टाइप्स आपको ध्यान में रखना है. So new aluminum lithium alloys have been developed recently for use by the aircraft and aerospace industries. These materials have relatively low densities between 2.5 to 2.6 gram per centimeter cube, high specific modulus of elasticity, right? Elastic modulus gravity ratios, right? Modulus, and excellent fatigue resistance and low temperature toughness properties. Furthermore, some of them may be precipitation hardened, right? Precipitate hardened किया जा सकता है. However, these materials are more costly to manufacture than conventional aluminum alloys because special processing techniques are required as a result of lithium's chemical reactivity. Right? Lithium is reactive, so you have to take care for that. Temper designations for both the wrought and aluminums are as follows, right? तो कुछ ये है nomenclatures है या F stands for fabricated, right? Or cold or hot working or by casting, right? O is for annealed, H for stain hardened by cold working, right? H for heat treated, W for solution treated only, right? These are the means nomenclature, right? अगर alloy लिख रहे हैं तो ये word use किया जाता है उसमें. So if you see these tables, right? So you should know, right? Composition and types, right? Compositions, right? Treatment conditions, right? And applications. I am not asked tensile strength, yield strength, and ductility, mechanical properties, how much these there, right? So there is no need to memorize these things. And even aluminum association number, UNS numbers, I will not ask that, right? So only you have to see for the composition and types, right? Annealed or treatment conditions and applications, right? आइडिया हो गया? तो टाइम लगाना पड़ेगा इसमें, ऐसे नहीं कि वन डे में हो जाएगा. Again, I will send this. Yes, any doubt?
No, sir.
देखो इसमें जो है वो पढ़ना है आपको, राइट? इसमें कुछ ट्रिकी वगैरह नहीं है जैसे मैथमेटिक्स में वगैरह है, राइट? प्रॉब्लम्स है, वो प्रॉब्लम्स भी इसमें नहीं है, राइट? एज इट इज यू हैव टू सी, बट अगेन
सर एग्जाम्स के लिए बस पीपीटी काफी है या बुक भी रीड करनी पड़ेगी?
PPT and I have taken from that book only, right? Kalpak Jain book, right? First you read from the PPTs, right? Afterwards you read from that Kalpak Jain book, right?
Okay, sir.
80 to 90% will be from the PPTs, right?
Okay, sir.
So that is there. 1 minute, I think I have to share this one. I have to stop it. Stop the sharings and then I will stick it. right? I have shared it with you, right, in the group also, to CR also.
Yes, sir. I will send it on the group, sir.
Okay, I have sent it, right? So no problem. Okay. कोई इश्यू है अभी तक के जो 3 टॉपिक्स हो गए इसमें, राइट? किसी को कुछ डाउट्स है?
No, sir.
यस, हेलो,
No, sir.
Yes,
Yes,
sir.
कौन है? वो यस सर वाला को क्या डाउट है? कौन बोला उसने? तो
नहीं सर,
डाउट्स है
मेरे
तो
को
पूछ
लगा
सकते हो।
नहीं सर, मेरे को
नहीं,
लगा आप
अच्छा।
कंफर्म कर रहे हैं कि साउंड आ रहा है या नहीं सर।
अच्छा, okay, then I will 56 students are there. I think again no roll numbers.
Sir, I will send the absentees list of both class, sir. Sir,
Okay,
okay, sir. Thank you, sir.
okay, then if you no doubt, then you can leave.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir,
Yes,
sir, morning you told about the project. Sir, can I make a program based on programming and which I am giving the details of different tools? Can this be an idea for innovative project?
different tools means
The different types of tools and the material studies, the manufacturing process, casting process.
but if you are doing programming, then it should run, right? You have to show me. If
Yes,
it is
sir, yes,
not
sir.
run, then I will cut the marks.
Yes, sir, it will definitely run. You will enter, you will ask, for example, you will ask for which tool and it will give you the details of that.
By submitting your innovative projects, what features you are going to add, right? Give that descriptions, right?
Descriptions of the casting process and manufacturing process.
Only which features you are going to add.
Okay, okay.
You will.
Yes, sir.
Okay, no problem.